Hello students. So in this video we are going to see example on superposition theorem and superposition theorem of circuits, superposition in the circuits containing dependent sources. Again now you can see here the dependent source which is there is that is your 4ix. 4ix is a voltage source which is depending on current ix. And we are going to use here superposition theorem. Superposition is required when there are more number of sources, that is independent sources. There are two independent sources here, that is 20 volts and 30 amperes. So what we are going to do here is we have to going to consider only one source at a time, and we are going to find the current, and then second source, and then we are going to find the current, and in the end we are going to add that two currents. The question is here, find current ix using superposition theorem. So we are going to consider one source at a time. Now in this circuit it has two independent sources, so we are going to consider these one at a time, and at the end we are going to add the currents, and this is nothing but the superposition theorem. Okay, so and if it has more number of sources, that we have to do for more number of sources. In this we have two sources, so we are going to do for two sources. So first we'll consider 20 volt source. So when we consider 20 volt source, what we have to do to 30 ampere, we have to make the current source 0. What do you mean by making the source 0? That means when I am making the source, current source as 0, we have to open the current source. And we are making voltage source as 0, we have to short the voltage source. Because when we say V is 0, it's short circuit. And when current is 0, it is open circuit. So when we consider 20 volt source, this current source will be open. Let us make the circuit. So this will be open. We are considering only 20 volt source first. Yes. When we are considering 20 volt source, that time that we cannot call this current as Ix, but we will call it as Ix dash, because this is not Ix now, because we have removed 30 ampere, right? So this is your Ix dash. So this also will be Ix dash, because this is a dependent source. If Ix changes, this changes. So Ix becomes Ix dash, this becomes 4Ix dash. Now we can find Ix dash in this. We can just apply, we can see there is only one loop. We can apply KVL and write the equation. What is the equation? It's 20. We are moving in the clockwise direction. So plus 20 minus 5 Ix dash minus 1 into Ix dash minus 4 Ix dash. We are moving in the clockwise direction. So plus 20 minus 5 Ix dash minus Ix dash minus 4 Ix dash equals to 0. So 20 equals to, take all this in the right hand side, it becomes 5 plus 5, 10 Ix dash. So from this, what is Ix dash is, we are getting it as 2 ampere. So Ix dash is 2 ampere. Name it as equation number 1, because we want two currents and then we have to add. So this is your Ix dash. Now second we'll consider is 30 ampere source. Now okay, second one we are going to consider 30 ampere source. Now when I consider 30 ampere source, we have to consider 20 volts as short. That we have to make the 20 volts 0. So this becomes 0 here, short. And this is your 5 ohms. This is 30 ampere current. This is your 1 ohm. And this is our dependent source. Now, as I have removed one source, that is 20 volt, we are considering only 30 ampere. This current we will call it as Ix double dash. This becomes here I4 Ix double dash. The resistors are same, 5 ohm, and this is 1 ohm. Right? Now, so we will call this as Ix dash. This we can call it as I1. And this is I2. This current is 30 ampere, right? Now, we have two loops here. So, we can say here we can apply the KVL, but we cannot apply KVL in say first and second loop. We have to apply KVL in the outer loop, because it has a current source in between. So, we'll apply, we can say here, what is I1? I1 is nothing but Ix double dash, right? then. And what is your I1 minus I2? You can see I1 is going down here and I2 is going up. So I1 minus I2 is 30 ampere. Right? So when I1 is Ix dash, can I write here Ix double dash minus I2 is 30 ampere. So what is I2? I2 is Ix double dash minus 30 ampere. So we'll use this. I1 is Ix dash and I2 is Ix dash minus 30. That means the current in the first loop is Ix double dash and current in second loop is Ix double dash minus 30. Now let us apply KVL. When I apply KVL in outer loop, I can write here minus 5 Ix double dash. We are moving in the clockwise direction, so we are moving here minus 5 Ix double dash, and the current here is I2, and I2 is what? Ix dash minus 30. So minus 1, and what is Ix double dash minus 30. So we are moving in outer loop, so minus 5 Ix double dash minus 1 in bracket Ix double dash minus 30 minus 4 Ix double dash. The voltage source is this, equals to 0. Now let us solve this. Minus Ix double dash minus 5 Ix double dash minus Ix dash plus 30 minus 4 Ix double dash equals to 0. Right? Now solve this. It becomes minus 5 minus 1 is minus 6 minus 4. So this is 10 Ix double dash equals to 30. So from here Ix double dash is 3. Now when I say Ix double dash is 3, this is your current for the second source. Now last step, that is third step, is total current Ix, and that will be as per the superposition theorem, Ix double dash plus Ix dash plus Ix double dash. It is 2 plus 3 equals to 5 ampere. So final answer is this. So this is easy because we are considering one source at a time, and the end we add all the current which we are getting to the getting through all the sources. This we can verify with finding the current with both the sources together. Thank you. For any queries, please write in the comment.